Building a weather-resistant shelter from the forest floor requires looking at raw timber not just as wood, but as structural potential. The builder starts by harvesting young, pliable branches. These slender shoots are chosen for their high moisture content, which allows them to bend without snapping under tension. In primitive construction, the materials dictate the design. Working with a simple hand saw limits the diameter of the harvest, forcing a reliance on engineering rather than sheer mass. It is a slow, deliberate gathering process. The goal is to collect enough flexible green wood to form a load-bearing skeleton. Before any frame can be raised, the foundation elements must be modified. Sawing a saddle notch into the main support poles creates a mechanical lock. This simple modification prevents the round timbers from rolling against each other once weight is applied. A flat edge, resting in a groove, distributes compressive forces evenly, ensuring the joints won't fail when the structure shifts. To anchor the base securely into the topsoil, the support logs are tapered into heavy stakes. Using a machete to shave away, the outer sapwood creates a wedge that can pierce compacted earth with minimal resistance. Tapering the ends rather than leaving them blunt prevents the wood from splintering when driven downward. A sharp entry point is the difference between a shallow rest and a deep, immovable anchor. Driving the sharpened stakes into the earth establishes the primary footprint of the build. The depth of these anchor points dictates the lateral stability of everything that will sit above them. While traditional bushcraft relies heavily on lashings, introducing modern steel nails accelerates the framing phase significantly. Nailing green wood requires a careful touch. The high moisture content allows the fibers to part around the steel shank, gripping it tightly as the wood eventually dries and shrinks. Adjusting the initial poles ensures the base frame remains perfectly square and level. A mistake here would multiply with every foot of elevation. With the square anchors set, the geometry shifts. Nailing flexible, curved branches to the rigid posts transitions the foundation from a square to a circle. Circular footprints are inherently efficient, maximizing interior volume while minimizing the exterior surface area exposed to wind and rain. Once the perimeter is established, the builder begins coiling long, pliable branches to create an elevated floor. Raising the platform off the soil is a critical survival principle. The earth acts as a massive thermal sink, drawing body heat away through conduction. Suspending the living space even a few inches creates a vital pocket of dead air. As the flexible branches are woven in a dense spiral, their overlapping tension turns individual weak sticks into a unified load-bearing deck. The floor effectively becomes a single, solid disc. Trimming the overhanging branches eliminates leverage points where accidental bumps could loosen the weave. The resulting platform is a clean, level surface ready to support the upper framework. Moving to the vertical structure requires a different caliber of timber. Gathering thin, straight saplings provides the ideal material for a vaulted roof. Tying them into a single tight bundle makes transport efficient, keeping the long whips from tangling in the dense underbrush. The architecture of the shelter lies on the mechanics of bent wood. By driving sharpened poles into the perimeter and arching them over the center, the builder introduces intentional, constant tension. The wood naturally wants to spring back to a straight line. When two opposing poles are locked together under this stress, their fighting forces cancel each other out, creating a remarkably rigid arch. This is the structural genius of the dome. It requires no internal columns, keeping the living space completely unobstructed. Securing the apex, where the flexible ribs cross, is the most critical joint in the entire frame. Using thin metal wire instead of natural cordage provides an immediate, unyielding clamp. Wire bites deeply into the soft green bark, creating mechanical friction that prevents the smooth poles from sliding against one another. As more arches are added and wired into the central node, the dome begins to support itself. Each new rib shares the downward load, transferring the weight evenly outward and down to the anchored foundation. The tension is distributed. The frame becomes a self-stabilizing cage. Adding bamboo introduces a material with an exceptional strength-to-weight ratio. The hollow, segmented structure of bamboo allows it to bend severely without crushing inward. Wiring these final flexible ribs into the apex closes the primary skeleton. The builder steps back to read the shape, ensuring the curvature is uniform. A balanced dome will shed wind from any direction. To lock the vertical arches in place, horizontal reinforcements are aggressively lashed into the grid. Twisting the wire tightly around the stacked bamboo segments acts as a tourniquet, clamping the intersecting nodes together. This horizontal ringing is what prevents the vertical ribs from bowing outward under heavy loads. The cage relies entirely on this interdependent geometry. Sawing off the protruding ends isn't just about aesthetics. It removes snag hazards that could tear the outer cladding. Every point of connection is checked and tightened. The skeletal structure is now a rigid, unified dome, capable of supporting hundreds of pounds of exterior insulation. Preparing to skintas the frame requires smaller interlocking pieces. Carving a sharp notch into a thin bamboo strut ensures it will sit flush against the rounded contours of the main ribs, maintaining the smooth exterior profile. Threading wire through pre-drilled holes provides anchor points for the secondary skin. Weaving thin, pliable bamboo strips horizontally creates a tight lattice network. This dense grid serves a dual purpose. It acts as shear bracing for the overall structure, and it provides a heavy surface area to grip the upcoming insulation. With the side panels fully woven, they are hoisted into position. Locking these prefabricated lattice sheets onto the main arches rapidly encloses the space. The wire bindings pull the flat panels taut against the curved ribs, forcing them to adopt the dome's contour. This rigid outer mesh completes the structural phase of the build. The focus now shifts from strength to shelter. A bare wooden frame blocks large debris, but it offers no protection from the wind. To insulate the shelter, the builder turns to the earth itself. Slicing thick, rectangular patches of sod harvests a perfect, pre-made building material. The dense root network of the grass acts as natural rebar, holding the dark, loamy soil together in solid blocks. Carrying these heavy slabs is labor-intensive, but the payoff is immediate. Pressing the damp sod against the bamboo lattice forces the soil into the gaps, locking the earth onto the wooden frame. As the patches are stacked, they create a massive thermal barrier. The thick layer of soil traps dead air and absorbs the sun's heat, completely blocking the elements. It is an ancient, highly effective method of climate control. Working her way up the walls, the builder completely envelops the framework. Smoothing the exterior edges blends the distinct patches into a seamless shell. Placing the final cap of sod over the apex is the most crucial step for waterproofing, as this is where rain hits hardest. A living roof is exceptionally resilient. The grass will continue to grow, its roots reaching deeper into the lattice to permanently bind the structure together. Inside, the environment is instantly transformed. The dense roof blocks the harsh daylight, while the woven floor provides a dry, elevated surface away from the damp soil. With the shelter secure, attention turns to sustenance. Arranging heavy, dense rocks into a tight circle contains the heat and creates a thermal battery that will radiate warmth long after the flames die down. Igniting a bundle of dry, fibrous wood requires high surface area and plenty of oxygen. The frayed edges catch the spark instantly, creating a rapid, intense heat source. Placing this burning tinder into the center of the pit establishes the core of the fire. As the initial flames catch the larger sticks, the carefully arranged rocks begin reflecting the heat inward, producing a steady, efficient burn for cooking. A large, flat stone provides a stable, clean work surface in the wild. Peeling and mincing wild shallots and pungent garlic releases volatile oils that act as powerful tenderizers and flavor enhancers. The methodical rhythm of chopping is a sharp contrast to the heavy labor of building. Preparing a meal in the outdoors is a deliberate process, demanding the same care and attention as framing the timber. The heavy labor of construction burns thousands of calories, requiring substantial protein for recovery. Working a heavy spice rubbed into the raw pork ribs begins the curing process. The salt in the seasoning draws moisture out of the meat, allowing the aromatics to penetrate deeply into the muscle fibers. Massaging the rub ensures a thick, caramelized crust will form once the meat meets the intense heat of the coals. Pressing the sliced garlic directly into the fat cap ensures the flavors melt down through the rack as it cooks. Wrapping the seasoned ribs tightly in aluminum foil employs an ancient cooking method, updated with modern materials. The sealed metallic envelope traps the evaporating juices, effectively steaming the meat in its own rendered fat and aromatics. This prevents the lean muscle from drying out over an unpredictable open fire. While the meat slow roasts, the remaining daylight is used to refine the camp layout. Using the hatchet to drive nails into a low frame creates a simple, elevated log platform near the entrance. Keeping gear, food, and firewood off the wet ground is a constant priority. Even a few inches of elevation prevents moisture from seeping into supplies. The work never truly stops. The campsite is continually improved, step by step. A momentary pause to brew a strong cup of coffee provides a vital morale boost. The sharp, bitter liquid warms the core as the afternoon begins to cool. Unveiling the foil packet reveals the result of the slow, steady heat. The trapped steam has broken down the tough connective tissues, while the concentrated ambient heat of the coals has managed to char the exterior. Lifting the heavy rack out of the juices, the meat is exceptionally tender, but holds its shape. The heavy blade glides cleanly through the bones. Cooking over a campfire is an exercise in heat management, relying on instinct rather than a dial. The deep, dark crust on the bark indicates the sugars in the rub have caramelized perfectly without turning to ash. This rich, calorie-dense meal is the direct reward for a long day of intensive physical labor. The rich, fatty meat provides immediate, sustained energy. Sharing the hard-earned meal reinforces the quiet companionship of the wild. Dogs are highly tuned to the routines of a camp, understanding when the work is done and it is time to rest. Tearing into the slow-cooked ribs, the success of the long day is tangible. The shelter stands, the fire burns, and the cold is kept at bay. As the sun dips behind the ridgeline, the temperature drops rapidly. The heavy layer of sod on the dome will now trap the latent heat of the day, shielding the interior from the oncoming mountain chill. In the end, structure, landscape, and daily routine operate as one system. It is a place that protects and sustains itself.